So remember that when you know two pieces of information out of three pieces of information, you can take that a lot of places. So, first of all, we've already mentioned, but it's not in our materials yet, but we've already mentioned that if I want to know the size of this angle, theta, when the ratio for tangent is 3 divided by 4, that we can just go ahead and go second tan of 3 divided by 4, and we find out that that's going to be a 37-degree angle or so. Let's draw it. So here's what this is telling you. This is telling you that if the tangent of theta is 3, that the y value in the ordered pair is 3, and that the x value is 4, because tangent is defined as y divided by x. So it's kind of like saying here's the ordered pair that passes through. So if x is 4 and y is 3, then our terminal side passes through that spot right there. And so I'm going to draw the right triangle so that you can see I forget what it was, but I think it was like 37 degrees or something. We just calculated 38 degrees for this theta right here, because this side is 4 units long and this side is 3 units long. So when I give you a ratio, I'm also giving you sides. Please don't forget that, because what I want you to find is I want you to find the sine of theta, which is defined as y over r, speaking of which you need to memorize, and the secant of theta, which is the reciprocal of cosine of theta. So what I do is I write down that cosine is x over r, so secant is the reciprocal of cosine, so that's r over x. So I need to find this one and this one for this problem, and I was given x and y, but I was not given r. And so I need to calculate r by the Pythagorean theorem. So get that program running, if you will, and find out what this hypotenuse is given these two legs. You have leg A and leg B. You have a 3 and a 4. If I did it by hand, I'd be putting in 3 squared plus 4 squared, and that would give you the square root of 25, and you would find that the hypotenuse is 5 for this right triangle. So sine of theta is the y value divided by the hypotenuse, the r value. So y is 3 over that 5. And secant is the r value, which is the 5, divided by x, which is the 4. Again, if I wanted to, I could come here and write cosine is 4 divided by 5, because that's x over r. But I just wanted two things. Let's do it again real quick. So sine is 1 over 2. So I've given you y over r, because that's what sine is defined as. So if I were to draw this picture, and it's just going to be a sketch this time, I want to draw this such that the y value is half of the hypotenuse. So I'm going to try to draw this, and I kind of want to do this with straight lines, and I'm going to say that this y value is 1 when this hypotenuse is 2. Again, 1 over 2. Y over r. So then I need to find out what the x value is by the Pythagorean theorem in order to describe tangent, because tangent is defined as y divided by x. And secant is the reciprocal of cosine again, remember, which is x over r. So secant is r over x. So no matter what, I've got to find x. If you used your calculator to do this, I think you would get 1.7. If you actually use the Pythagorean theorem, you'd take the hypotenuse squared minus the 1 leg squared, which is 4 minus 1, which is the square root of 3. So again, 1.7, I think 1. Well, I just again want you to know that our author is going to use the square root of 3, not the 1.7. So when they go to fill in these values over here, and they write down that the tangent is the y value divided by the x value, 1 divided by the square root of 3, then they're going to rationalize the denominator and multiply top and bottom by the square root of 3, so that tangent is called square root of 3 over 3. Because remember, this square root of 3 times the square root of 3 is the square root of 9, which is 3. And there's no radical in the basement. For secant, which is the other thing they ask for, secant is r, which for us is a 2, over x, which is the square root of 3. And to rationalize that denominator, again, I got to multiply top and bottom by the square root of 3. So in the numerator, I have 2 square root 3. You can't do anything with that. In the denominator, I have 3. So tangent and secant is what I was looking for. Finally, last problem that I want to do. So the first two were given as fractions. This one's given as a decimal. You have a couple of options. You can think of 0.371 because the 1 is in the thousandths place with a THS at the end. You could think of that as a fraction and call it 371 over 1,000. And you now have a fraction for the cotangent of an angle. You could also leave it as it is, 0.371 over 1. I mean, 1 in any denominator gives the original value as well. It's up to you. So if it's 0.371, just put it over 1. Or you can call it this. So again, we've got to draw a picture of this because I'm not very familiar with cotangent. Maybe you aren't. And so cotangent is defined as the reciprocal of tangent, which is x over y. So these values are x over y. So the x value is smaller than the y value. So I'm going to draw something where the x value is much smaller here than the y value. And I guess I'll just stick with the 0.371 for x and the 1 for y. And then let's see if I have the hypotenuse for this. Via your program, I have 1.067. And then finally, I just want an approximate value for these ratios. So cosine of theta is defined as x over r, and x is 0.371, and r is 1.067. You're even welcome to go ahead and do the division and call it 0.347. It's up to you. A value of a trig function can be written as a fraction or as a decimal. Now really, fractions never have decimals in them, so it is more proper to do the division here. Tangent is defined as y divided by x. So in this problem, my y value is 1. My x value is 0.371. When you divide those two numbers out, you get 2.695. So we're just getting used to writing the values for sine, cosine, and tangent in terms of x, y's, and r's. Given two pieces of data in the triangle, we use the Pythagorean theorem to find the third. We're going to continue on now and start looking at particular angles